Hey everyone, in this video we are going to be learning about quadratic roots and the discriminant. So let's get started with quadratic roots. So what are quadratic roots? They are the point where the parabola intersects the x-axis. So we've kind of heard of something like this before when we talked about lines, the point where something crosses the x-axis. So quadratic roots are also called x-intercepts, point where the graph crosses the x-axis. They're also called solutions, and they're also called zeros. So it is important to know that these words all mean the same thing, and personally, I will use them interchangeably. I'll call them roots, or x-intercepts, or solutions, or zeros, and they all mean the same thing. They all mean that we're talking about the point where specifically the parabola intersects the x-axis. So this is like so important to understand the terminology and that these all mean the same thing, and they mean specifically the point where the graph or the parabola crosses the x-axis. So a parabola, a quadratic equation, has three options for the number of solutions, or the number of roots, intercepts, zeros, for x-intercepts specifically. There's three options. Option number one is two solutions, basically two x-intercepts. So a parabola that crosses the x-axis twice. That would be an example of two solutions. A parabola can also have one solution, one zero, one x-intercept, and that would be a situation where the vertex is on the x-axis. So the vertex is actually on the x-axis. So there's only one solution. There's only one place where it crosses the x-axis. All right, only one root. Or a parabola can have no solution, meaning it'll never cross the x-axis. So what would a parabola look like if it will never cross the x-axis? Well, maybe the vertex is over here, so it'll never cross the x-axis, or maybe the vertex is over here and it's downward facing, so it'll never cross the x-axis. So multiple options for parabolas that'll just never intersect with the x-axis. So that's a situation where there's no solution. So one solution, again, is when the vertex is on the x-axis, so that's just the one point where it's going to touch the x-axis. And then, again, two solutions is a parabola that goes through the x-axis on either side. So we're actually going to start off by looking at solutions, looking for solutions of the quadratic equations, but we're going to do it first by graphing. And later on in this unit, we're going to learn other methods for finding the solutions that are a little bit faster than graphing. But for now, since we're new to this, we're going to look for these x-intercepts, these solutions, these roots, these zeros. Right now we're going to look for them by graphing. So we're going to graph the parabola and then find the x-intercepts on the graph. So taking a look at number one, you see that it is in standard form. So since it is in standard form, we got to use x equals negative b over 2a to start building our vertex. So let's do that, negative b over 2a. So the x value of my vertex is negative 2. And the y value of my vertex, let's find that y value of the vertex here by plugging in x. So 4 minus 8 minus 5, negative 4 minus 5 is negative 9. Okay, so my vertex is at negative 9, negative 2, negative 9. So let's put that in the middle. 1, 2, 3, 4, 5, 6. Oh, they gave us 7. All right, no problem. We'll put it right in the middle of our table. And let's build the rest of our table. Nope. Negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1. All right, I'm going to build on these small numbers right here and then use symmetry to build those. So here I have built the table of values. I plugged in negative 1, 0, and 1. I already know by looking at this table of values that I'm going to have a root right here and right here. And the reason is because roots, solutions, zeros are x-intercepts. And in an x-intercept, it's a dot where the graph crosses the x-axis, which means the y is zeroed out and the x has a value. So let me prove that to you by graphing. So let's go ahead and graph this parabola by plotting all the points onto the grid. All right, so I've got my points on the grid. I'm going to connect my parabola, nice U-shaped. You see here those points I was telling you about. I was telling you about the points -5, 0, and 1, 0, as I already know that that is where it was heading, okay? So these are the two x-intercepts. So we do have two solutions because we have two x-intercepts. And the way you say the solutions, well, the solutions are, the x-intercepts, the roots are x equals -5 and 1. So -5 and 1 are the two solutions for x squared plus 4x minus 5. And then sometimes you'll see them in, in braces just to show that those are two answers. But you can also write -5 and 1 in words. Okay, so let's take a look at number 2. Starting to build my vertex here, -b over 2a gives me a 1 for the x value. Plug 1 in to the quadratic to get y, the y value of the vertex. So 1 minus 2 plus 1, that makes 0. Oh, look, a 0 in the y value. I have a feeling there is my root. So 1, 0 is my vertex. And if my vertex is on the x-axis, let's zoom back out here. If my vertex is on the x-axis, that means that this parabola is going to have one solution, okay? So I'm going to just build the rest and graph it, and then we'll write down that one solution, that one x-intercept, that 1, 0. All right, so here is my graph, and here is my one solution. As I have one x-intercept, that's a solution, that's a root, that's a 0, and that is happening at x equals 1. We already knew that because of our vertex. So our one solution for number 2 is x equals 1. Okay, so I already went ahead and started number 3. I found my vertex, same rinse and repeat, -b over 2a. Plugged that x value back into the quadratic to get the y value. So there's my vertex at 1, -2. I built my x values, plugged them in, and used symmetry to get the following y values. So let's go ahead and graph. I can already tell as I'm plotting these points, it's going to be obviously a downward facing parabola because a is a negative number. All right. I have a feeling we're going to have no solution here, but let's finish graphing this. I've got -6 here, 3, 4, 5, 6, -6, and then -11. All right, I'm not going to put that last point. We'll just go down here. It's good enough. All right, because we're really just trying to answer the question of how many solutions. We've got enough points to build the parabola. We can see that it never crosses the x-axis. And since it never crosses the x-axis, this parabola has no roots. No real roots. You'll learn one day what imaginary roots are. It has no real roots. It has no real x-intercepts, no real solutions. So we're going to say no real solutions. That's right, no real solutions. No real solutions here. So big information here about the number of solutions, big information here about the terminology, what solutions are, and that they can be called roots, solutions, zeros, but ultimately they are x-intercepts. How you can find them by graphing, okay, just by pointing them out. And then how you say your answer for those solutions. So that is the conclusion about quadratic roots. We have not discussed yet the discriminant, and we will talk about that specifically in class, what it is and what it's used for and why we like it. And thanks for watching Quadratic Roots, and we will do more practice on finding quadratic roots by graphing in class. Thanks for watching.